That was an amazing morning. I'm thrilled to be here. I'm so grateful to the team in Tel Aviv for organizing this event and bringing us all here. It's so far been an amazing experience. My name is Cora Iverclyde. I'm a developer advocate for VMware, and I'm going to be talking to you about Spring Cloud Gateway, which is not as new as the other stuff you've seen this morning. Is this okay? Yeah? Is it not as new as the other stuff you've seen this morning, but it's a really useful project, and it's easy to use, and it's cool. So, how many people here are already using Spring Cloud Gateway? Okay, a few. Okay, awesome. Okay, cool. But enough not. So, the concept of an API gateway is probably familiar to a lot of you, and it's especially as we move towards microservices. An API gateway can play a lot of roles in a microservice architecture, right? So if you have, for example, if you don't have a gateway, then you would have to, of course, configure from every client application to every server-side application that they need to use all of the individual connections and manage those. But as soon as you stick a gateway in there, it simplifies the setup, the configuration, and it gives you new opportunities for cross-cutting concerns. So everything from routing, right, from that gateway to whatever service is in the background. Cross-cutting concern example is security, of course. So the developers responsible for the individual applications don't all have to worry about implementing security. You just do that in the gateway. It's a perfect opportunity to introduce monitoring. If you also want to do some kind of canarying, deploying different versions of things and controlling how much traffic goes to each, also weighted routing as well. It gives you an opportunity to improve the resiliency of your application by saying if one microservice in the backend fails, what kind of remediation action can I take without causing cascading failures? And then if you want to refactor your application into more smaller services, then you can do that without impacting the client experience on the left-hand side. So there's really a lot of use cases for a gateway. And in particular, there's sort of traditional large gateways that are often operated by an operations team and for which you generally have to go from one team to another to ask for permissions or registrations of APIs. And those are great for monetizing APIs and things like that. But Spring Cloud Gateway is a really lightweight way to introduce gateway functionality into your particular application architecture, and it's in the hands of you as a developer, right? So it's for use cases that really have to do with where you want more control, and it's within, it's Java. So so at the end of the day, there's a Spring Boot starter, so you introduce it into any Spring Boot application, and that makes it a gateway. So it's very approachable for if you're in the Spring ecosystem. So just some basics. It was built as on the reactive stack, and so it's also very fast. Because again, if you think about introducing something that's going to be in the way of all traffic between a client and your backend applications, then you don't want to introduce any delays, right? So it works very quickly, and one of the reasons it works very quickly is because the reactive stack introduces this non-blocking sort of event loop. So as requests come in, they get queued, and then there's a callback later for when the response comes back. So very, very fast. So you'll see when it starts up, it uses Netty, not Tomcat. And so this is the model of how it's constructed. And so these are sort of like the primitives that you're going to be working with if you are configuring a gateway for yourself. So as a request comes in from a client, first it goes through some handler mapping using things called predicates, which help you say, well, these requests, I want to handle them in this way, and these other requests, I need to handle them in this other way. So you can define different paths for different kinds of requests, and you set up those rules using predicates. Once a request comes into the gateway, you also may want to modify it before you send it to a backend service, and you can do that using filters. There's all kinds of filters. And again, you can also modify the response. So some examples of predicates, you can route things differently based on and the documentation has a complete list, so I'm just highlighting date and time, headers, the different, put, get, etc. The remote CIDR address. You can do weighted routing. I'll show you that in a few minutes. So a lot of options in terms of how you choose to categorize the requests that are coming in terms of what you do with them. And then filters. You can change almost anything about the request. Headers, parameters, you can modify the body of the request, and then you can apply rules, so circuit breaking and fallback actions for resiliency. rate limiting, you can save a session, things like that. And then you can apply global filters. You can also set default. Some of your filters don't have to be route specific. You can set default filters for all paths, and then some filters for certain specific paths. There's also global filters. And on the response, before you send the response back to the client, you can also apply further filters. So it's very flexible. And so the idea of a route is the building block of a gateway. And so as your requests come in, you're going to define which path are they going to take, both to the backend service and on the way back. And so that idea is a route. So every route that you define has to have a unique ID and a destination where it's going to go. And then, of course, the rules for how you divide requests among routes and the filters that you apply. And the other great thing is that, of course, for Java programmers, your most natural inclination might be to just open up a class file and start coding Java. But a lot of this is actually available through DSL, so through your application properties configuration. And so I'm really going to focus on showing you that, because I know that as much as you all are super excited, I'm a better YAML programmer than I'm a Java programmer, so I'm going to show you the very simplest way to do this. Plus, it has the advantage that if you put your configuration in a properties file, then you can put that on Spring Cloud Config Server, and you can very easily change the behavior of your gateway and just restart your application, right? So I'm going to show you most of this through a demo. Very simple. If you would go to initialize a new project, these are the requirements that you need. And resilience is there for the circuit breaker. I'll show you that. And Redis is there for rate limiting. So if you're not going to use rate limiting, you don't need Redis. If you're not going to use circuit breaking, then you don't need the resilience for J. Okay, so let's start here. And okay, so right now I'm going to just keep Redis, set the management configuration to false until we get to the demo that uses that. But basically, we could just start to configure routes, right? We have this concept of routes, and as I mentioned, every route has to have a unique ID, and that ID can be anything. It could be something a little bit more meaningful. I'm just going to call it, this is my first route. Now, so when a request comes in, if it qualifies to be part of this route, where do I want to send it? And I'm going to use, instead of writing a backend application, if you're familiar with httpbin.org, it's a great little application that just sort of lets you write HTTP methods against it. It has, in particular, some methods for dynamic data. It has one that responds with a UUID. So this is going to simulate, this is going to act as our backend application. And you can see that if I would hit this URL right here, that I would just get a UUID back, right? And in fact, we can do that here. We can curl this address. Same thing, right? Okay, so that's where we're going to send traffic. Now, we're actually going to send all traffic to that, not just UUID. But if something comes in, so this is how I'm going to evaluate requests that come in, and if the request has the path UUID, then I'm going to send it to that website, and I'm going to add and it's going to transfer that UUID to the end of that URL. So it's that easy. So if we start that up, assuming I typed everything right, then that should work. So now, instead, I'm going to use HTTP instead. Instead of calling, so now on my local host 8080, if I just add UUID, then the request hits the gateway, and the gateway should forward it to HTTP bin, and we get the response back, right? So really easy. And so I'll just go through a few more examples so you can get the full kind of flavor of it. So predicates are additive. So I can say, for example, I want to control that not everything can go through so easily, but I'm going to require a specific host. So let's restart that. And now if I try to send it like this, then that won't work, but I can set a host here, example.com, and I can resend that, and now it works. So really, really easy to build this up. Okay, so those are predicates. So let's go into filters a little bit. Now we want to make some modifications on the request. So let's say I don't want to expose to my clients the exact API. So HTTP bin has their own API, but that's not the experience that I want to expose to my customers. I want this to be something like maybe demo. So then in my filters, as something comes in, that matches with demo, what I want to do is set the path to something different. And so here I would want to set it to, UUID, right? So we can then restart that. I'm really excited about all the announcements this morning because the next time I do this demo, all these restarts are going to be faster. Yeah. And wait, why did that not work? Set path UUID. Oh, yes, thank you. Okay, awesome, right. That's right. Let's change that to demo. Right, okay, so now the client has a different experience and they're shielded. And so this is sort of like the refactoring the monolith, right? Or just presenting a better API experience, even though your APIs in the background might be more complex. Okay, awesome. So then let's do a little bit more complicated stuff. So HTTP bin has another great example here called drip. I like this one. So if we try this one out, let's try this out. So basically you can set different values on the query and it will introduce a delay. You can control how many characters you get back, etc. And so you can see that it's taking a little time because it's introducing a delay. It's waiting a few seconds before. It's putting a few seconds between bytes. But essentially, the request looks like this. So how would I do this over here? So what I want to do, obviously, is add query parameters, right? Add request parameters. So there is a filter precisely for that called add request parameter. And so I can, for each one of these, so let's say duration is 1. This one introduces a delay before, so let's just set that to 0. And then I'm going to copy paste here. So then we'll say the number of bytes is going to be, let's say, 10. Then we'll say the code, we want a success code, so we'll say 200. And then finally, we want a delay. And another nice thing we can do is we can parameterize. So I can add here, so if you say demo slash, and then let the delay be dynamic. So we'll restart it. And did I set path? Oh, thanks. What would I do without you guys? All right. Oh, this one. You're right. Okay. That makes more sense. All right. Team effort. All right, restart. You're going to edit the recording, right, Oded? All right, so now we can add a delay here. And let me actually add the timer at the beginning so we can make sure that it does take longer. And let's say we add about a 4-second delay. So seems like it's doing it. Awesome. All right, so we got 10 characters back, 10 stars with a delay. Okay, so I mean, it's like, I think it's amazing because it's pretty powerful stuff with just some configuration. And once you understand the configuration, of course, you can go into the Java and do all the same things, right? So what if, okay, now I have, let's see. Oh, you know what? I meant to do that. Let's do this. I meant to do that as a second route. So let's pretend that I did that this way, and we did a route 2 here, and that we had left this the way that was before. And so this was UUID, and let's go back this way. Okay, so now let's say I have 2 routes, right? So now, but if I do add a star here on this route, then the question becomes, which route is it going to choose, right? So who votes for route 1? Who votes for route 2? Okay, see a lot of abstained votes. Okay, so let's try it out. So we started again, and now if we run that same thing, It should actually, did it restart? Did I restart it? Let me try that again. Oh yeah, we chose the first one. Okay, so we thought, yeah. So it actually is choosing the first one. And we know that it's choosing the first one because we're getting a UUID, we're not getting stars, right? So if you do have two matching routes, it's just going to take the first one. But let's say we don't want to do that. Let's say we actually wanted to use weighted routing between the two. So that is another predicate. So we can simply say weight, and we would have to assign it to a group. They both have to belong to the same group, and then we assign a certain weight. And so we're going to do the same thing on the second one. And now we expect it to go back and forth. So I'm sure the people who didn't vote, I'm sure this is what you were thinking. So, all right, let's do that. So it's not exactly, it doesn't always come out like, it's not round robining, but more or less. So there's the stars. More stars, and there's the UUID. So, more or less, it's kind of balancing the load. So really easy. This used to be really complicated to do. Now I'm more nervous. No, you can do whatever you want. All right, so who's implemented weighted routing before? Was it this easy? No, not this easy. Okay, so awesome. So weighted routing. So the next one I want to show you, this is also cool. This is also harder to implement. If you've used Hystrix before with a Spring Cloud architecture, you've seen this before. So circuit breaking. So let's do that over here. So this is our route that can introduce a delay. And we don't want end users to have a bad experience, so we actually want to introduce a circuit breaker. And for circuit breaking, you have to choose an implementation. So there is a circuit breaker, not filter. It is a filter. There is a circuit breaker filter. But you have to choose the implementation. So in this case, as I showed you in the Spring Initializer screenshot, I'm choosing to use Resilience for J as the implementation. And so you do have to do a little bit of configuration for that. Resilience for J can also be configured using DSL, so you don't have to go into the Java for this, but I happen to have this defined in Java with a default timeout that will time out if a request is 4 seconds. So I'm going to leverage this. This is the only one that I have. So if I go back here, I can just give it any name, actually, my circuit breaker. And then I would expect that to activate the circuit breaker on this route. So if I retest that, and let's introduce, just to make sure that we absolutely hit it, let's introduce a 10-second delay. So we're expecting that after 4 seconds, the circuit breaker will time it out. And in fact, we get a gateway timeout. Super easy. And then, of course, this is not a great experience for an end user. So what we want to do is have a fallback action. Like if it's a timeout, give the user something else, right? So for this is the sort of the shorthand way to define this circuit breaker. But we can break that up so that we can provide more configuration. So what we would do is say, call it a circuit breaker. I don't know if I don't remember I need a colon there. I don't. And so then this becomes, we're going to give it a name. Oh, here. So okay, so this is the longhand. So we name the filter, and then we provide arguments. And so in the case of resilience for J and circuit breaking, oh, you know what? Sorry, I'm getting two things confused here. But okay. So args. The only thing we need to do is define what the fallback is. All right. So we need a fallback URI, and so I want to forward this somewhere else, preferably because let's say I'm having network issues. Maybe I want to do something locally within this application. So where do I want to forward this? I'm going to define. I have another controller here that declares a /fallback/ID that's just going to return all zeros. So basically, if I can't return the UUID, I want to return this. So I'm just going to say forward to /fallback/ID. You can also configure this to send it somewhere else over the network, but this is the way I'm going to do it. So, okay. That should work. Oh, you know what? I don't know if that'll work, so let's see. There, okay. All right, so let's try that out. So again, we have our 10-second delay. And so now after 4 seconds, there'll be a timeout. But instead of a timeout, we should get, let's see. Oh. All right, okay, let's get rid of this guy. And this one. All right, okay. Okay, so 4 seconds now. And we get our fallback action, okay? So that's cool. Okay, this is where my mind was going before. Okay, so another really cool use case is rate limiting. And so for this one, the other thing that's cool about this is that for rate limiting, basically what rate limiting means is that you're going to keep track of how many requests are coming in within a certain time frame. And if you get too many requests, you want to maybe buffer them or reject them just to manage the load on the system. So for this one, let's define another. So for this one, if you keep track of how many requests are coming into the gateway per second in memory, then if you scale the gateway, then every instance of the gateway is going to be keeping track of its own number, right? So you're going to maybe limit it to 100 requests per instance, but once you have more instances, and you may want that because your rate limiting may be based on the capacity of something that's behind the gateway, or you may want to respect that limit no matter how much. You may want the freedom to scale your gateway. Let's say you're protecting some kind of like pay system, or you're just managing maybe trial usage. So in fact, let's say we are doing that. We're setting up a trial for users, and you want to limit their utilization by a service so that you can encourage them to pay. In that case, you might want to set a rate limit. Okay, so let's create a new ID. So we'll make this route 3, and we're going to send it to our same trustee endpoint here. And we'll set the predicates. This time we'll say that, make this different, so the path will equal, so let's say we have trial users. And in this case, we want our filters. We'll again, set path. We'll use the UUID again because it's nice and quick. So here, we're going to use the Redis rate limiter, or request rate limiter, which is Redis based. So for this, of course, what we need is an instance of Redis. So let's go ahead and start. I'm just going to use Docker. Okay, so we start Docker. We have an instance of Redis, and of course we want to now enable Redis over here. And okay, so now we're going to rate limit, but what is the rate limiting that we want to do? So just for demo purposes, because we want to see it in action quickly, I'm going to set the Redis rate limiter to like 2 requests. And there's a couple of properties I need to set. One of them is going to be a replenish rate, and the other one is going to be a burst capacity. So really, roughly 2 requests per second of capacity. So once I restart that, that all looks good. Then we can just say HTTP bin 8080 trial, and let me set the verbose output here. So what you can see here is that, so the request goes in, and on the response, it's actually added some headers to the response, these X rate limit headers, and so it's kind of keeping track of what's going on. And so actually, we want to see it actually put the rate limiting in action, right? So let's run this command. So we're going to run 10 commands in a row. I'm using curly because it's a little bit faster than HTTP, so we'll hit the rate limiting, and it's just going to do 10 in a row. So you see a couple come in, and we see too many requests. Okay, so Oh, it didn't work this time. Okay, let me try it again. Sometimes if the network slows things down a bit, then it doesn't work. Okay, there we go. So, based on network speed, sometimes we get 2 requests in a second, but then after it reaches a limit, you can see that it's keeping track, and you get too many requests. And you can combine that, of course, with a circuit breaker and do something else, or just encourage people to pay for your service. And the last thing I want to show you, so definitely check the documentation, because there's more, in particular, there's more filters to play with. And of course, you can combine this with Spring Security. Right now, the way that it was counting 2 requests per second was based on 2 requests for the whole application, because I defined what's called a key resolver, and I'm just returning a 1. But you could combine this with Spring Security and say you want to keep track of how many requests per second per user, right? Something like that. Now, the last thing I want to show you is that now that you understand these concepts, it's really easy. There's certain things you can't do in DSL. There's certain things for which you need to resort to Java. And for example, modifying the request or the response body. But once you understand that, then it's really easy to understand the Java syntax, because you're building routes. So every route, of course, has to have a unique ID. So we're calling this one modify request body. And we're going to say if something starts with post, we're going to use this. And what we're going to do is just take the content. I don't think I need that anymore. We're going to take whatever's coming in the body, and we're going to upperclass it. We're going to take the JSON and send it to uppercase, and so we'll see that the request looks a little bit different. So this has already been in there the whole time, right? We don't have to restart it. I think I have it here. So if we say, okay, so we say echo hello Tel Aviv directly to http://bin.org, right? So we would expect this to look like post. All it does is it bounces back. So because http://bin.org is just there to help you test HTTP requests, so it's just sending you back. So now if we send that through the gateway, which is running on 8080, now we expect to get the JSON back with an uppercase of all the content. So we've modified the response body. And that's actually all I have to show you. I think I have like one slide with information that might be useful. So if you want to look at that stuff in more detail or check the documentation, but it's an incredibly powerful project. It's very, very easy to use, and so I encourage you to look into it. So that's all. Thank you.